Hello. Today we're going to talk about data. Now, data is just numbers that describe information or something that's happening. Data is everywhere. Right now, as I'm making this video, we're in the middle of this social distancing due to the coronavirus. And in the beginning, when the virus first came to America, we did not have much data. So the government reacted very cautiously and said, okay, we got to lock things down because we don't know how dangerous this is. People are getting sick and dying. And now it's been about, I want to say 2 months, and we have more data. And the government is now able to say, we can tell a little bit more about how many people are getting sick, how many people need to go to the hospital, and how dangerous this really is. And using this data, we can now act. Now, data is not just the coronavirus. Data could be your bank account. Data could be how many people are working at your company. Data could be your favorite sports team, your favorite sports athlete, and their statistics and how well they do. There is a report that I heard recently that 90% of all data in the world was created in the last 2 years. So if you want to know a skill that will help you in the future, you should understand data. Okay, so today what we're going to talk about is how to use Desmos to find data. And we're going to have some key vocabulary over here. Just want to go over this. We've got forward statistics. This is analyzing the numbers in the data. We're going to make a dot plot, a box plot, and a histogram. Those are the things we're going to do. Okay, so the first thing here, and I'm going to point, the first thing here says split your screen, right? Now we can go vertically or horizontally. I'm going to use my mouse. Hopefully you can see it. I'm going to shrink my screen to a smaller size. I kind of already had it set up. Here's my Desmos on the left side. Here's my notes on the right side. You're probably going to do something just like this, except you're going to have a video on one side and Desmos on the other. And in the video, you're going to hear me talking, and there's going to be questions. Now, because I know Desmos does a lot of work sideways, and I like to have my side space, I'm going to go like this. I'm going to grab the corner of this page, and I'm going to shrink it down to here. And I'm going to take this page, and I'm going to pull it up. I'm going to pull it up, hopefully. There we go. So this is what you can do with your Chromebook or your laptop. If you have two machines, that's great. On one machine, you put the video. On the other machine, you put the Desmos. All right. So now we're going to talk about some of the things. We've done the first step. We've split our screen, and now I've gone, so I have two horizontal screens. It makes it easier for me. The next thing, we're going to enter data by putting a letter. So that means up here in this box on Desmos, you're going to put a letter. If you put a capital letter, it works. Most capital letters work really well. So I'm going to just D for data. Doesn't matter. It's going to have the equal sign and a bracket. Then we put our numbers in. Okay. And then we'll talk about the keyboard function. So let me just scoot down, and I got some data right here. It says, construct a dot plot to display the scores on a recent math quiz. The data are blah, 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 these numbers. And there's 1, 18, 19, 20, 21. There's 21 data points. The lowest data, if we look at this, the lowest data is 0. The highest number on my data chart is 15. So it goes from 0 to 15. If I go over here to my graph, and I could do this manually, I've got, let's say I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Well, I don't have 15. So what I'm going to do is I'm going to count by twos. It goes 0, 2, 4, 6, 8, 10, 12, 14, 16. I don't need the rest because it stops at 15. You can do this manually. I'll remind you. So I'm going to cross out the 12 and put a dot above the 12. A 14, an 8, a 13, 12 and 14, 12 and 14, 5 and 13, 5 and 13, 14 and 3, 14 and 3, 15, 15, 15, 15, 14, 13, 14, 13, and 10. Okay, I have made a dot plot. They call it a dot plot because it's got a bunch of dots plotted on a graph. So what I'm going to do is I'm going to show you how to do the same exact thing, but using Desmos. Okay, so I got my letter D up here. This is my data. And down here, I've got my numbers. My notes said to put the numbers in with commas. So I'm going to go 12, 14, 8, 13, 12, 14, 5, 13, 14, 13, 10, 14, 13, 10. It says I have 21 elements. That's what it's supposed to be. Do I have 21 dots here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, I graphed mine correctly. So what I'm going to do, I've got my letters in. That's right here. Check my numbers in with I named it D for data. Then I'm going to go to screen keyboard. That's right here. That's the screen keyboard. This is my note. Functions button. I'm going to the functions right here. And what I'm doing up here is stats and dist. Stats is for keeping track of numbers and calculating stuff. We're doing that one next week. This week, we're just going to show the display or the distribution of the data, and I'm going to do a dot plot. Oh, I didn't want to put it there, so let me erase this because I want to put it on its own line. So function, dot plot. Now, what it's saying here is, in the parentheses, I need to put the name of my data. So D, that's my dot plot. Does it all fit? Well, I'm going to go like this. I'm going to say zoom to fit. Is it all in? There we go. There's my data. Does it look just like my original one I did down here by hand? Pretty good. It looks a lot nicer than mine. So that's what I want you to be able to do. One thing is create a dot plot right here. I want you to be able to find this keyboard function, the functions button, and do the distributions. Oh, and being able to adjust your screen, that's setting this zoom to fit. So now it fits. Okay, that's a dot plot. Let's try another one. A box and whisker plot. So I'm going to close this one down. Let's go here. I need a new name. Let's call it B for box and whisker plot equals this. Now, the number of miles from school that a number of randomly chosen students live. The data are 5, 10, 15, 12, 1, 14. It says there's 16 elements in the list. Let me just check and count really quickly. 16, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, I got all 16 typed in. It is telling me to make a box and whisker plot. So I go to this thing, the next box, functions. I'm looking at my distributions and a box plot. That's your box and whisker plot. And they're saying, we're going to make a box plot of what? And that inside that parentheses goes the name of my data. My data is B. It has made a box and whisker plot right here. Let's see if I can scroll it up. There it is, box and whisker plot. I could zoom to fit the data. This right here just tells me how far away from the x-axis it's going to be. I can put it far up. I can make it right there. I can make it right on top of the x-axis. Might be harder to read, so I move it up. The height is basically saying how tall do I want my box to be? What makes it easier for you to see. There we go. So now I've made a box and whisker plot. We're going to talk about what this means and how to look at it and how to read it. Okay, so that's next week. This week, I just want you to be able to make it, and on the next page, we're gonna graph a little bit. We're gonna talk about the graphs. Okay, so that's a box and whisker plot. I could put it right here, and I could copy the data down. I'm gonna have to count by twos again. And this line right here is at 1. This line looks like it's at 5, 6.5. 10, 11, 14, and the top one is at 15. Box around the middle 3, whiskers out to the sides. So I could do it by hand. I could copy it down. All right, the last one we're going to do, creation-wise, is going to be a histogram. Construct a histogram to display the scores on a recent English quiz. The data are blah, 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 and we're going to type this data in. Since it's a histogram, maybe I'll call it H equals square bracket 18, 45, 20, 32. Okay, so I've made my data set. It says 15, there are 15 elements. I will always check my work. It says right here that there's 15 numbers or elements in my list. I will count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, it says make a histogram. Well, I'm in the next box right here. So I go to functions, histogram. That's the one we haven't used yet. So histogram, I'm going to put the name in the histogram, H, and it makes a histogram. Well, this information down here says use X is between 0 and 10 as the first interval. Well, that's talking about this right here, a bin width. I'm not going to be very worried about the bin width and all that. But right there, I just set my bin width to 10 wide. That means each of these right here, this bin, this first set of data is 10 wide. But it's weird because it's starting here at 5. It should be starting at 0. That's because if you look over here, I'm going to point to it. Oh, bar alignment, I need to align left. So I'm going to move my mouse over here, left. Let's look at this now. I want to see it better. There we go. All the data is in one place. And I don't want it I want it by count. Okay. So I've got my histogram set up. This data looks really nice. It's a lot since this is a quiz grade, there are a lot of students right in the middle. There's some on both sides and fewer on the ends. Okay, we will be talking about that next. I'm just gonna go down here, make sure there's nothing else on my list of things to check. No, there's not, so I go to the next page. Because we did these, we adjusted our screen by clicking on that button, which made the graph fit the screen. So I'm gonna go to the next page. We're gonna talk about interpreting the data. So how to interpret the data or graphs, basics. We'll be doing more detailed stuff next week. This week is just the basics. First thing we're going to talk about is data spread. Is the data wide and loose, spread out a lot, or is it really tightly packed and narrow? Well, if this represents test scores or quiz grades, and the highest grade is a 50, I'm thinking everyone's pretty much spread out. I would much like it if all the students were in one big group. Like right here, if I look down at the bottom of the screen, I got this data set. This is the height of the home team in inches. This is the height of the other team in inches. This data in the middle, there's more people in the middle than on the outside. So this is more tightly packed. This data has in the middle, it's not crowded at all. It's really spread out. So this data spread is widely spread or loosely spread out, something like that. I just want you to be able to look at it and compare it and think about how tight is the data. The next thing we're going to talk about is distribution. In distribution, we're talking about if it's skewed, symmetric, or skewed. So let's look at this really quick. Down the page. What we're going to do is if I have a lot of data where, let's say this is where most of the data is. Oh, wait, no. Median. Yeah, this is where most of the data is. And then there's just a couple out here on the right-hand side. We're going to say it's skewed right. If I have most of the data on the right side, but just a couple on the left, we're going to say it's skewed left. If the data makes a nice mountain or it's all just spread out evenly, we're going to call it symmetric, which means pretty much the same on both sides. And if we look at this graph of the quiz grades, the histogram is really symmetric. I mean, it looks great. The next thing, okay, let's check for understanding here. Based on what you just heard, is this skewed left, symmetric, or skewed right? There's your note. There's your graph. If I graph this, it goes like this. This is where most of the data is. If these were your math quiz scores, and these are all your scores, which ones are not normal? Where are they? And I'm going to say that the normal ones are over here. Those are not your normal quiz grades. Because look at this. This is a nice hill. These grades, maybe you were sick that week, whatever, something, but those are unusual. Those are the quiz grades you make up. So we're going to say this is skewed left because the left side of the graph is unusual. Okay, let's try it again. I'll use a different color, easier to see. What about this data? This is talking about the student heights in Mrs. Carson's math class. Since it is pretty much most of the students are in the middle, we can say that this is symmetric. 2 M's, symmetric. How about this one? A fishing derby results. A fishing derby is a competition where people go out and try and catch fish. Well, where's most of the data? Most of the data is right here. You've got a couple that are out here. When we look at data like that, we might even call these outliers. We're going to talk more about outliers next week, but I'm just doing a visual check. If there's data that's not normal and it's outside my bubble and far away from the bubble, we're going to call that outliers. So this data that's skewed left, this quiz grade, and definitely are outliers. This one, look, it doesn't look normal. It should be in here somewhere because these are your quiz grades. You get 12s and 13s and 14s almost all the time. An 8 is not normal. So let's just check our We talked about how tightly packed it is. Yes, skewed left, symmetric, skewed right. And we're doing visual checks for outliers. This one is symmetric. This one is weird. It is, I would call it symmetric, but it's not tightly packed. And let's see if we got another one. Okay, this is a box and whisker plot. Where is most of the data? Is this tightly packed? Is this symmetric? Is it skewed? Okay, I'm going to say here's the center of the data. Here's the right side. Here's the left side. This is unusual. So I'm going to say this is skewed. Where's the unusual stuff? On the left. Now what I want you to do is put this one into a dot plot and tell me, is it, how tightly packed is it? And is it skewed or symmetric? And then I'll probably put a couple more onto the Ed puzzle. Hope you enjoyed.